Here's a quadratic equation in factorised form. It's very common in complex numbers to have quadratic expressions like this, where the roots 2 plus 3i and 2 minus 3i are complex conjugates, and multiplying out these brackets involves certain tricks. So we're going to do the example twice, first of all showing all the detail. The first step, of course, is to multiply each element of the first bracket by each element of the second bracket. Now we'll need to tidy up the z term by collecting these bits together and find the constant term by multiplying out these brackets. Because 2 plus 3i and 2 minus 3i are complex conjugates, two very special things are happening. First of all, in the z term, the imaginary bits are going to cancel, so the coefficient is real. Also, in the constant term, because they're complex conjugates, we've multiplied out the brackets using the difference of two squares. Now, 3i all squared is 9i squared, but I squared is minus 1, so this equals minus 9. Taken together with the minus that was in front of that term, we've got plus 9. So all the coefficients have turned out to be real, and that was bound to happen because the roots were complex conjugates. It's extremely important that you understand this detail, even though you wouldn't necessarily have to write it all out in an exam. Here now is the minimum working you'd need to show in an exam. Z times Z is Z squared, and the coefficient of the Z term is going to be the sum of these two bits. As we saw before, the imaginary part cancels, and we're just left with minus 4Z. For the constant term, we need to multiply those two terms. They're both negative, so it's going to come out to be positive, and it's the difference of two squares that we're using. So as we saw before, it's going to be 2 squared minus 3i all squared, which is the same as 3 squared. So the quadratic is z squared minus 4z plus 13 equals 0.